Hello and welcome to the lecture. So, in the previous lecture, we have studied about the concept of enantiomerism and the concept of diastereomerism. Now, in the previous lecture, already we have studied that when the two compounds, they are not mirror images of each other. They are not mirror images. They are not, and on rotation, if they are identical, they will be if on rotation they are same. If on rotation they are same, then the compounds, they will be identical. They will be identical. And if the compounds on rotation, they are not same, then at that time the two compounds, they will exist as diastereomers. They will be diastereomers. So this was the concept that we have already studied. Now let us see that the diastereomers, the physical properties of diastereomers and the physical and chemical properties of diastereomers, they are different. So the physical and chemical properties, they are different. Now let us see some examples so that we can understand in a better way the concept of diastereomerism. Now let us see, we have this group CH3 like this. Here we have here OH, here we have H, and here we have OH, here we have H, and we have here ET. Now let us draw the mirror image of this very compound. We will look what will be the mirror image of this compound. Now let us see, first of all, let us draw the same compound with different arrangement. Suppose we have CH3 here, and here we have H, here we have H, here we have OH, here we have OH, and here we have ET. Now as you can see that these compounds, if we rotate these compounds, they will not be identical. Also, these are not mirror images of each other. And they have two chiral center. Now if we can say that these compounds, they will exist as diastereomers. They will be diastereomers. Now using R and S nomenclature, there is an easy shortcut way with the help of which we can understand that the compounds will be diastereomers. The thing is that you must understand that two chiral centers, they are required for the compounds to show diastereomerism. Now let us see here. Suppose if we have in a first compound, if we have RR configuration, now let us look here. If we have the configuration like, if we have RR in one compound and in another compound we have same configuration, that is RR, then at that time the two compounds, they will be identical. Similarly, if we have, suppose in one compound, if we have RR in one compound and in another compound, if we have RS, or if we have like RR in one and in another compound we have SR. Now this is the condition for diastereomerism. Diastereomerism. That is, if in one compound we have RR configuration and in another compound we have R and S, then the compound it will exist as diastereomerism. And if in one compound we have RR and in another compound we have SR, then the compound it will exist as diastereomerism. And if we have the configuration like RR and in the next compound we have SS configuration, then at that time the compound it will be enantiomers. The compound at that time it will exist as enantiomer. It will exist as enantiomer. Now let us see some examples. Like if we have the compound like this, CHO here, and here we have like this. Here we have H, here we have OH. Here we have H and here we have OH. Now if we, and here we have another the mirror image of this compound like this, OH here, we have here OH, and we have CHO here, and we have CH2 OH here, and we have here H, and we have here H. Now let us see here. Since these two compounds they are mirror images of each other, so it means that when they are mirror images, and also as you can see that they are non-superimposable on each other. Now if you can see that, let us write down the R and S nomenclature for these two compounds. Here we will have one, this will have R configuration, and this will have R configuration also, and here this will have S configuration, and this will have S configuration. So it means that the configuration for this is R and R, and in its mirror image the configuration is S and S. So as you can see that there is altogether shift of the configuration. So it means that these two compounds they will exist as enantiomers. They will be enantiomers of each other. Similarly here, let us see one more example. Suppose we have like this, COOH, and here we have H here, and we have OH, and here we have OH, and here we have H. Now here what we have COOH, and here let us write down its mirror image like this, COOH, and here we have OH here, here we will have OH, here H and H, and here we will have COOH. Now here the configuration it will be R, here it will be S. Similarly here the configuration it will be S, and here it will be R. Now as you can see that these two compounds they are mirror images of each other. They are mirror images of each other. Now since these are mirror images and the configuration is R and S, here the configuration is R and S, and here S and R. So it means that these two compounds the configuration it does not change. It means that also as you can see that here there is plane of symmetry present. There is plane of symmetry present in